Alright guys, welcome to Systems Day. What we have here is, you look at the screen, we have a red cart, and we have it attached on the string over a frictionless pulley to a hanging mass. And what this hanging mass is going to do is it's going to fall. And so the question is, what is going to be the acceleration of the hanging mass? Here's your choices. When we release the cart and mass, what will be the acceleration? Decide, and then after you've decided and said why, come back and we'll take a look. Alright, well, you had a chance to think, you had a chance to predict. So what we're going to do is we're going to actually show the hanging masses falling. So I put them side by side, I drop one, and we observe. What you see is the one that just falls by itself hits well before the other one. Video's a little choppy. If you're in class, you saw it then too. So the question is, why would that happen? So what we're going to do is we're going to take a look at this, and so we're going to answer this one question here. What will be the acceleration of the 50-gram mass if there's no friction? So when we turn the air on, we don't have friction. And we're going to walk through these ideas. So let's start off by looking at what we have. So we have, initially, we have a pulley, small hanging mass of 50 grams, and we have this cart over here which has a mass of 300 grams. So let's look at my system. So whenever we look at multiple objects accelerating together, we look at the system. And when we look at the system here, what we see is, here I've got a weight force, I've got a normal force, and I've got a tension pulling this guy. And this guy, I've got a weight force, and I have less of a tension here because he's accelerating downwards. So this guy's weight force, I do 50 grams, convert it, multiply it out, I get half a Newton. And so if I think about my system, and I think about F net equals ma, for my system, the only thing that's accelerating my system is this weight force. This guy over here, his weight isn't accelerating anything. His normal force isn't accelerating anything. It's just this guy's weight over here, that's the piece accelerating it. Now here's the catch. What is the mass that's being accelerated? Now, is just the 50 grams being accelerated? Or is just the 300 grams being accelerated? But instead, both of them are being accelerated together. And so it's the total mass. So I've got 0.35 A, solve that out, so I get 0.5 divided by 0.35, which is going to be about, I'm making up numbers, I'm hoping these are close, 1.62 meters per second squared. Notice this is not 10 meters per second squared.